Hello everyone, in this video we are going to see about the multivariate testing. Let us see the definition. Multivariate testing serves as a vital statistical framework for comparing different machine learning models to determine which produces superior results. So here we create many machine learning models and we test the model using much of the data. And we try to choose which is the best model to be implemented, that is which gives the superior results. So that is tested by the multivariate testing. This is mainly involved with the statistical framework. That means we are using the statistical formulas. This methodology involves establishing a null hypothesis to check if a new model truly improves the performance or if observed changes are merely coincidental. That means we check the model and based on the model we check the performance. If it is truly improving, we choose the model. Okay, or the model gave the result just as a coincidental, means just for some reason the answer may come, the result may come in a better way. That is called coincidental. Let us see the fundamentals of multivariate testing. So we are having the hypothesis, null hypothesis and alternative hypothesis. So here this multivariate testing is a method of statistical hypothesis testing used to determine which model is best for a specific problem. Okay, so for that we need two hypotheses. It involves two hypotheses, null hypothesis and alternative hypothesis. The null hypothesis, it is H0. The new model does not affect the average value of the performance metric. So here this hypothesis assumes that the new model will not change the average value. Performance metrics are various metrics of a model. For example, if you choose a particular, suppose you are learning about a car. Okay, so there we have the speed and the frequency which the brake is given and the gear component. So many things we consider to judge the speed of the vehicle. So that is the performance metric. And the alternative hypothesis HA, this defines the new model does change the average performance metric. Okay, so here we assume that the new model changes the average metrics and we keep on improve the hypothesis. So these are the two hypotheses, null hypothesis and alternative hypothesis. Let us see the testing process. The testing process, in order to do the testing process, the student should be able to outline the following 4 steps in conducting these tests. First one, split the population into randomized control and experimentation groups. So we have the model is of higher dimension, data is of higher dimension. First you have to split the population into randomized control or experimentation groups. So based upon randomly we can choose a group, or we can based on some condition we can choose the group. Then we have to record the behavior based on the proposed hypothesis. So either we may use the null hypothesis or alternative hypothesis. Based on the hypothesis, you have to record the behavior of how the model works. And then compute the performance metrics and their associated p-values. So based on this particular data or the hypothesis, how the performance metrics varies. So that is found out, and the associated p-values also find out. So p-values, it ranges from 0 to 1. Accordingly, the values are determined. Then the next step is decide which model to proceed with, which based on the results. So accordingly, we have the null hypothesis, we have the alternative hypothesis, we have some group of data. So repeatedly check the model using different data with different groups of population, and then we have to find out which is the best result. Then the third step in this testing is key statistical concepts. What is the statistical concept is, we use different statistical methods to learn the model. First one is the correlation versus causation. What is the correlation measure is, it measures the size and direction of a relationship but does not imply that one variable cause the other. That means here there is it's a correlation measure. That means the size of the data or the direction means the flow may go in a positive or a negative way. So the upwards or downwards, that the flow of the process varies, okay, and the size of data also varies. So this correlation measures the size and the direction of the relationship, but it does not imply that one variable causes the other. Means which it assumes that every variable is independent, nothing is dependent on one another. So individual variable, what is the performance? That is the correlation concept. Whereas and the causation means the occurrence of one event is directly related to the other event. So we talk about the cause and the effect. That means if parameter 1 is working, then it depends on parameter 2. Then that may depend upon parameter 4 and 5. That is the dependency between the parameters which we choose. So causation does not actual causation check the dependency between the one parameter or other parameter, whereas correlation does not depend on the variable causes that affects each other. And then we have one-tailed versus two-tailed test. So one-tailed test only evaluate if your model is better than the original. So we have original model and we test against the original and observation values. If the observation is better than original, then only we have to use the one-tailed test that evaluates the model is better than the original. Two-tailed test means it chooses both the negative and the positive side. That the model may work negatively or positively, but it will take the consideration with the both the direction. That means both positive and negative side. It's called as a two-tailed test. And the third one is the statistical power. This is the probability that the difference detected during test reflects a real world difference. Okay, so how much it really cooperate with the real world values. That is the difference. That's the statistical power. And then we have the effect size. This determines the difference between two groups by evaluating the standardized mean difference. So it uses the formula mean of experimental group minus mean of control group divided by standard deviation. This is the formula which calculate the effective size of the data we are using. Then the next is the understanding the p-values. So the p-values are evaluated from the machine model, and this p-value represents the strength of evidence against the null hypothesis. That means how it is towards or against the null hypothesis. So we have values p less than or equal to 0.05 means it's a strong evidence that null hypothesis. It is an against the null hypothesis. The result is statistically significant and null hypothesis rejected. Okay, this is the condition. Second condition is if p is greater than 0.05 means it's a weak evidence against the null hypothesis. So the null hypothesis maintained. And the third is p is equal to 0.05 approximately. This considered the marginal and could swing either way. That means if this is the case, the value may go this or that way. Okay, so this is how the p values helps to evaluate the machine learning model. Then the data distribution and variance. This is the next concept in multivariate testing. Here we have different test type. T-test often used to analyze difference between the means, but they assume a Gaussian normal distribution. So we calculate the formula using assuming the Gaussian or normal distribution, and then we evaluate the values, and then we find the difference between the means of different values. That is the t-test. Then is the non-parametric test. If the distribution is not Gaussian, students should know to use the test like Wilcoxon-Mann-Whitney test, which does not make distribution assumptions. So that means the t-test assumes the Gaussian and normal distribution, whereas this non-parametric test does not assume any distribution. Okay, and then a Welch test, t-test means this is used when the control and experimentation sets do not have the equal variance. So here, as we know, we have different control group and experimentation group, and when they do not have equal variance, they find out the variance. Applying the variance formula, the two groups are evaluated, experimentation group and the control group. Then based upon this variance. Based upon the variance only the t-test works. Okay, so this t-test is used when they do not have the equal variance. That means the variance are different in both the control group and the experimentation group. Okay, and next is the practical consideration. So practically how to involve the testers. We have the novelty effect. This describes how short-term user reactions to a change like a new layout may not represent long-term behavior. Running tests long enough to overcome this bias is crucial. So novelty effect is something new is found out in a particular model, which is a short time. Okay, so this describes the short-term user reaction. Some immediate changes are made and the effect is studied with the user experience, and that is called as a novelty effect. And this test we cannot run for a long period. Okay, and if that is done for a long period there will be a bias. Okay, and then distribution drift. Ongoing monitoring is required for after deployment to compare live data against the baseline. So we have the baseline data, which is the static data. Then also we have live data which comes in randomly in a real-time world. So what happens is we have to monitor ongoing monitoring. You have to always check on the values after deployment. Once you design the model, you once you confirm the model, that model has to be deployed. That means it has to come into existence. After executing the model, it will give some live data. Okay, it will give some real results. So that result is compared by the live data with the previous experiment with the baseline data. Baseline data is the static data, assumed data, and live data is the real-time data which comes in dynamically. And then this significant changes in validation metrics may require the model to be retrained on new data. So any significant changes happens in the calculation which we find out in the monitoring, so that validation metrics will help to choose the model or we reject the model. And then logging, maintaining a log of model changes provides a physical record for the stakeholders and technical governance. So log is nothing but that's a record of an event. So here when we change the model, so when you have an old model, we have some values, record all the values. Then we change the model, again record the values, and then provide that we are choosing in a physical record, and then that will help for the technical governance. Means in the future it will help to find out which is the best model to maintain, whether the old model or the new model, or we can change between the new model and the old model. So log always helps to know the record of information what has happened in the history. So that's all the components of the multivariate testing. Hope it is simple to follow, and thanks for watching.